So, my name is Alejandro Castañeira. I am the principal data scientist at Jans Technology. This is the outcome of today's presentation, hopefully. So Jans Technology is a Swiss technology company which is operating in the field of human resources. We mostly provide governmental services to some countries like Norway and Paraguay. And we also provide business-to-business solutions to some of the most known players like Stepstone or Indeed. Why recruiting is still a relevant problem even in today's days? So it's a huge market. It's a 250 billion market, and there is still a lot of lengthy hiring procedures. So most of the recruiters, they complain that normally for very demanding positions, you have a long row of candidates and you have to screen among all these resumes. Also, when you are applying for a job, you normally are doing keyword searches and you try to find the right keywords to put on LinkedIn, on a link, so that you will have better suggestions. So why this is happening even in today's world? So according to a recent research, only 7% of the market is actually using advanced analytics or deep learning and so how. These are typical suggestions of daily recommendations that you will get on, let's say, LinkedIn. By example, you can get for a graduate in human rights, you can get the suggestion of a meat industry expert. So I don't know if it happens to you every day that you get recommendations that are not actually relevant to you, but this is a very common issue. So how we are solving this issue at Jans Technology? So the first thing is that we need a better representation for data. So we have to represent jobs and CV in a way that they are comparable. In this sense, we have we call this representation a Jans vector. So a Jans vector is no more than a vector that has all your competence. So basically, these are your hard skills, the things that you have acquired during your career development. We will not be using any type of personal information like your name, gender, ethnicity, where are you coming from, and all this type of bias information that can lead to biased processes. So once we have the data in this type of representation, if we are able to compare jobs and candidates, we have this in the same representation, we can make a match. We can make a complete match which should be explainable and should be transparent for both sides. You can see this matching as a way also to up-level your skills. It's very good it's very nice to have a type of educational benchmark for job markers where you can see where you are lacking or how you can correct your current resume or how can I improve other my competency. This is completely explainable, it's transparent, and it's not totally based on deep learning. So this is not like an algorithm that you say I put my CV, I put a resume or a job description and I have a score. No, because I don't think even for us as data science, we will just be like to be ranked by a linear regression of a deep learning model, because at the end we know that there can be some outliers in there. So how do we actually compute this score? So how do we compute senior data scientist equivalent to a Python developer in somehow? So the way to do this is to do some algebra with concepts. So we cannot just assign numbers to occupation and skill. The way we are going to do this is through an ontology graph. So we have an ontology of HR data where we are going to describe the relations in the knowledge graph like the similarity that we are trying to obtain for making comparison. So let's say like an anesthesia nurse and a clinical care nurse are 40% similar. This is the degree of similarity that we are going to use to calculate the match score. So in order to have this type of similarity, we will need a huge knowledge graph. So this was the main competence of our company. We have been building this knowledge graph for the last 10 years. It's completely hand-curated, so we have many curators in different languages that they populate this knowledge graph with their relationships. So this is a broad overview of the recommender system. So the first step, you have candidates and resumes or job descriptions that they have in any format. We are going to pass this to a parser, which is going to give us the structured information. Then we are going to expand this information with the knowledge that we have from the ontology knowledge graph. And then we are going to calculate a match score. So this system can also be included in Eterna's platform, like we are doing for some of our customers, like Indeed or Stepson by example. And then I am going to describe now which are the different parts on the different deep learning models that we have incorporated into this process. We have, by example, the first part is the parser. So we all know that there is no standard format for CVs. There have been some attempts to make this like having some common format or template for everyone, especially in Europe, but this has not been possible. So we have to structure this information. We have developed a parser. It works in more than 40 languages. It's capable to process several types of documents like PDF, Word, JSON, for example, and is able to extract different entities from jobs and resumes. Then the first step in these parsers is the name entity recognition. So name entity recognition is the process to extract name entities, so which are the relevant topics for our field. In this case, will be occupation, skills, education, and so forth. So how this model was developed? So this is the deep learning model that we are using. So we have pre-trained a BERT language model. So we have a language model, but they are trained in open domain. So in order to have better representation, we will have to pre-train in a large corpus of jobs and CVs. So we gather around some millions of jobs and CVs. We pre-train our BERT model, and then on top of that, we train a standard sequence leveling model, which is a conditional random field. This will give us just the tags, is a text belong to an entity or not. After we have this information, we are going to extract also the proficiency level that you have in a different skill. So it's not just necessary that you say, okay, I can work in Python, but to which extent can you do it? How proficient you are? So we have to also to extract different granularity levels. In this case, we have multiple granularities for education, for skill, for occupation, and so forth. And we did this with a self-attention network, similar to the mechanisms that are used in the transformers. So we are going to pay attention to the mention itself, and we are going to pay attention to the context of the mention. So this is highly contextual. Depending on the context that you refer to a given skill, we are going to assign a proficiency level. This is a self-attention network with multiple heads. It's similar to the encoder that we use in transformers model. We also have to relate the named entities. So basically, in a CV, of course, you have your information more or less structured. In a job description, it's not always the case. So you can have reference to date at the beginning of the job description, and you can have it at the end. This makes it a little bit more difficult because typical entity relation models, they always operate at the sentence level. In this case, we have to operate at the document level. For this sense, we use a graph neural model, which we basically will try to associate the entities around the document and try to create relations that using a graph embeddings. And at the end, we'll just produce a vector where two entities are related or not. We also have to normalize of the extracted entities, like people write in their CV Java in so many different ways, also in job description. So you can write Java programming skills or programming in Java coding language, but they also refer to the same semantic knowledge, so it's Java. Then to make this normalization, we will have to use semantic encoders. We use sentence verse encoder, which they are pre-trained in general language, so we have to fine-tune this in our domain language. So we have to give them pairs of data, of pairs of skills, pairs of occupation, and say how related are these to a skill or not. So, as you may say, we have a lot of processes that require a lot of supervised data because this is a very sensitive concept. We should not do any unsupervised learning in there because nobody would like to be a play around with their skills or their resume. So we have a lot of supervised data. The way that we collect this data is using Prodigy. This is an annotation tool, maybe many are familiar with it. We have, as I say, many multilingual curators that they gather this data on a daily basis for multiple languages. And this is how with this data, we train our model. This is the workflow of how we are deploying this model into production. So basically, we collect data for many of the tasks that we are handling at the moment, and then we keep the measure of how these models are performing. After we collect enough data, we retrain our model, we test to see their performance, and if they are doing better than their previous models, then we deploy this into production. The good thing about this process is that normally we can change not only our data, but we can change our model every time this a new technology comes to the NLP scenario. We have not made, like, let's say, any major breakthrough of transformers model or new deep learning specific architecture. This is just a pipeline of good practice of the current state of the art in deep learning, and I think it's a very safe way to approach this process into our application. Then the final step of this recommender system is to index these documents in a search engine. So after we have our data structure, after we have already our resumes or job description, they are in a standard format. So we have them already, like these CIDs are ontology concepts. These are all your data will be represented, all your skills or competence are represented like an ontology concept. Then we are going to index this in a search engine. The search engine that we have been using, we are using two types of search engine. One is PostgreSQL and the other is Elasticsearch. We incorporated Elasticsearch a few years ago. It has been proven to be more performance than Postgres, especially for when you are querying for millions of job ads. When we have a new job description or a new resume, the first that we do is try to expand. After we process it, we are going to expand the knowledge that we have from this job description. So, by example, if you input in your resume, I don't know, I have JavaScript skills. So basically, we are going to expand to related concepts. So maybe he knows a little bit about Java, or he knows a little bit web design or CSS. So we are going to search also for alternatives, so you don't have to specify like very strict keywords when you are searching for a job vacancy. Then this is running currently in production, and it's also being used to get some, besides the typical job matching, we also do some analytics. So after you have all the information structured, that you have your competence with your high proficiency level, you can make a lot of different analytics, especially for broad sectors. If you are a government, you want to see how your job market is behaving. So you want to identify education gaps, or which is the difference between your current educational system and your job market. This is running currently in production in several countries, like Paraguay and Norway, by example. I think we got to the end of the presentation, if you have any questions.
Thanks, yeah. We have time for some questions, so there's one there.
So thank you for the presentation. Could you please elaborate a bit more on how you're performing relation extraction? Because I know there are several ways to do that, from open information extraction to supervised learning, which effectively translates into taking like text and trying to classify it, like whether it's corresponding to relation of type A, B, C, or none. And you were talking about embedding like the extracted entities into graph, and then you classify the graph. Maybe if you could elaborate a bit more on that.
So for entity extraction, maybe I will put on this slide again. Just a second. Yeah, it's this one. So for entity extraction, so first we have the name entity. So the first step is to get the name entities, of course. It's a little bit tricky case to have an actually entity relation model that works in a document scale, because many entity relation models, they just take two entities, maybe in a sentence, and they assign if they are related or not. So we actually find a paper, we find one, that actually have some pre-trained model and code that works, and you can pre-train on your own domain data. I can give you the name of the paper if you want. I think it's called Double Graph Relationship Extraction Model. So it basically, it represents the whole entities. You have all your entities. Each entity will be like a graph. Each entity will be like an edge on this graph. And then you want to predict if between two edges they are connected. This is broad overview. And this works like first, if you notice in here, we first have to make some type of coreference resolution. So the entities that refer to the same semantic entities like IT supporter, Lloyd Aéreo Boliviano, they are all grouped into the same cluster, like into the same edge. And then we are trying to predict the relationship between those edges. So actually, this is not just one single graph, it's a double graph entity relation model. And after what you will get at the output is just a list with all the entities in the document and a confidence score of relationships. Like these relations, we have the relation, they have classes, because you can have different relations. Like in a job or a CV, you can have, I have worked it, I studied it, I got this grade, or I have these skills. So it's kind of a softmax classifier at the end of the entity relation model. And it gives you the confidence score by classes between two age in this entity relation graph. If you want the paper, I can give it to you because I know it's very hard to find somebody that works for entity relation. Yeah. We struggle a lot to find, it's not a topic that has been so much published and shared in the last few years. Yeah. Sorry?
So I saw that you're basically matching the skills, right, that you extract from the CVs of the candidates.
Yep.
Let's say if I was looking for a job, is the best strategy for me to just list as many skills as possible? Because to me it seems like your algorithm would favor CVs like this.
I mean, there is also, we use many stuff like skills, education, experience, and so forth. There are many dimensions. So first is like, you have to have, let me put this slide just a second. Here are the list of the stuff that we use. Yeah. So first you need, I mean, even if you list a list of skills, is how many of these skills are required in the job description. You can list 1,000 skills, but if the job description just has 10, basically you will just be matching with these 10. And we really don't reward too much to overqualified candidates because the job description is just asking for this skill. And there is also the dimension if you are lying in the CV. You know, it's not that I am going to put whatever skills I want just to have more match. They also have to be true. And the proficient levels of these skills plays a role. So by example, if you have more, you are overqualified, right? You have more skills, but your proficiency level in the skills that you describe with the ones that the job description are asking, if I am a Python level 5, even if I am Python level 5, the job description is asking for Python level 4 or 3, and you have 20 skills, but the Python level 5 is the one that are more relevant for the candidate, for the job position. Also, this is not in the recruiting. This is good to know. This is just giving suggestions. There are the two sides in this process. One is recruiting and the other is hiring. We are in the hiring part where we are just screening. So we just give to the recruiter a long list of candidates, like let's say the top 20 candidates, and they make the hiring decision. It's just a way to save time for them. Yeah.
Okay, there's many more questions. I hope you'll stick around during the day and tomorrow and come find Alejandro.
Yeah.
Thank you.